Okay, ladies and gentlemen, we are now going to solve radical equations, which is just another word for when we're taking square roots. So for a couple warm-ups, if we're solving x squared equals 64, to get for x, what we do is take the square root of both sides, and then we get x equals, and the square root of 64 is 8, but remember we have plus or minus 8. Now here, if we have the square root of x equals 9, to get rid of the square root, we can square both sides, and then we get x is equal to 81. In looking at equation C, I can see I want to get x by itself and square it, so I know that I have to get rid of the minus 4, so I'm going to add 4 to both sides and get the square root of x equals 10. And then squaring both sides, we get x is equal to 100. So equation D becomes a little bit more complicated. So to get rid of that square root, we're going to square both sides. And then I get 2x squared minus 121 equals x squared. And now I'm going to get all the x squareds on one side by subtracting. And 2x squared minus 1x squared makes x squared minus 121, and then equals x squared minus x squared is 0. Now I could solve this with a quadratic equation, but I notice that I don't have an x term, so if I add 121 to both sides, you get x squared is equal to 121. And then you can take the square root of both sides, and then you get x is equal to 11. And remember, it's a square root, so plus or minus 11. So now for example A, what we're going to do is get the radical equation by itself. So I'm going to subtract 4 first. And my resulting equation is the square root of x plus 3 equals 6. Then I'm going to square both sides. And the resulting equation is x plus 3 equals 36. Subtracting 3 from both sides, we get x is equal to 33. Now, I can go back and check my answer and say, is the square root of, and for x, I'm going to plug in 33. 33 plus 3, and then plus another 4 equal to 10. Oh, and I wrote plus 4 instead of plus 3. So 33 plus 3 gives me the square root of 36 plus 4 equals 10. And then the square root of 36 is 6 plus 4 equals 10. And we can tell that we did a correct equation. So now we're going to check this solution and solve it. So in solving this equation, I'm going to square both sides to get rid of the radical. And I get 2x plus 3 equals x squared. Then I'm going to move everything on the other side of the equation. So I'm going to subtract 2x and subtract 3. So then I get 0 equals x squared minus 2x and then minus 3. And then I'm noticing that I could factor this. So most of you guys are using the area model nowadays. So I'll make that area model. Here's x squared, and then here's minus 3. So then that breaks up into x and x. And then for minus 3, I need factors of negative 3 that add together to be negative 2. So I know that the only factors of negative 3 are 3 and 1, and that I need the negative number bigger. So I'm going to put minus 3 and then a positive 1. So this is going to factor into x minus 3 times x plus 1. And then I can set both equations equal to 0 and solve. So we have x minus 3 equals 0 and x plus 1 equals 0. Adding 3 to both sides, we get x equals 3. And then in the second equation, subtracting 1 from both sides, we get x equals negative 1. So now what we're going to do is check our answers. So we can check with a calculator. To do this, what I'm going to do is plug in this function on this side, y equals the square root of 2x plus 3. And then on the bottom one, we're going to plug in y equals x. And then we're going to graph both. And I'm going to zoom in. So let me just change to zoom 6 or zoom standard. And then we will calculate our intersection. And we have an intersection at x equals 3 and y equals 3. So we see that this is an answer, but this one is not. So what we're going to do is always look for what are called extraneous solutions, or solutions that may be on here that don't make sense. So our calculator solution, if I draw a picture, we had a solution at x equals 3. And then plugging it in, we can do for x equals 3. We had this 2 times 3 plus 3, all in a square root, equals 3. Then if I do some work, 2 times 3 is 6. And 6 plus 3 is 9. And the square root of 9 is equal to 3. So that, in fact, worked out. And then if we plug in negative 1, the square root of 2 times negative 1 plus 3 is equal to negative 1. So looking at that, 2 times negative 1 is negative 2. So we have negative 2 plus 3 is equal to the square root of 1. And the square root of 1 is not equal to negative 1. So this is not a solution. So we need to see that when we solve some of these equations, we have to check our answers to make sure they're actually a solution. So now, ladies and gentlemen, just a reminder that when you solve an equation by squaring both sides, you cause extra solutions to appear. These don't work in the original equation. They're called extraneous roots. So they're extra. It is therefore important for you to always check solutions to determine if they work. So what we're going to do is solve this and check for extraneous solutions. So if I square here, we would see 5x plus 4 is equal to x minus 2 times x minus 2. And now I'm going to distribute on this side. So x times x is x squared. And then x times negative 2 is minus 2x. And then negative 2 times x would be minus another 2x. And negative 2 times negative 2 would be plus 4. So we get 5x plus 4 equals x squared minus 2x plus 4. So I'm going to collect my like terms on the right-hand side and get x squared minus 4x plus 4. And then on the left-hand side, we have 5x plus 4. So now what I'm going to do is subtract these both over. So I'm going to subtract the 5x over. And I'm going to subtract the 4 over. And I get 0 is equal to x squared minus 9x. And then these cancel out. And what I notice, I could use quadratic formula, but this x squared minus 9x is factorable. I can factor an x out. So 0 is equal to x times x minus 9. And then using that zero product property, we can set both of the factors equal to 0. So we know that x equals 0 and x minus 9 equals 0. Oops, I wrote 9. My bad. So then add 9 to both sides, and we get x equals 9. So we have two solutions, and now we have to make sure we don't have extraneous roots. So what we're going to do is go and check each. So if x is 9, we would have the square root of 5 times 9 plus 4 is equal to, substituting in 9 minus 2. So here, 5 times 9 is 45, plus 4 is 49. So underneath our radical sign, we have the square root of 49 is equal to 9 minus 2 is 7. So we know the square root of 49 is 7. So that checks. And we just need to check if x equals 0 is an extraneous solution. So in checking that, 5 times 0 plus 4, and then we'll see if that's equal to 0 plus 2. So I'm looking at that. 5 times 0 is 0, and 0 plus 4 is 4, and the square root of 4 is 2. So it looks like both of our equations are solutions, and we can verify graphically. So if I just turn on my calculator, clear out the solutions that are in there. On the left-hand side of the equation, I'm going to put in the square root of 5x plus 4. And then down here, we're going to put in x minus 2, and then graph those. Oh, and I actually made a mistake here. I was like, 0 isn't a solution on here, but I came up with one. My mistake here, it's x minus 2. So this would be 0 minus 2, and we have the square root of positive 4 is negative 2. And that is not a solution, so I came to the wrong conclusion. So this is an extraneous solution. So now here, what we're going to do is graph this equation. So we're going to put in y equals 3 minus the square root of x. This is going to be what we put in for y1. And then here, the square root of x minus 3 is y2. And we're just going to graph both. So first, if I have 3 minus the square root of x, the first one that I could graph would be 0. So if I put in 0 there for x, 3 minus the square root of 0 is 0. So I would be at 3. And then I'm just going to also try to do so if I could think about perfect squares. So the next perfect square is 1. Square root of 1 is 1, and 3 minus 1 would give me out 2. And then if I plug in the next perfect square, which would be 2 squared, which is 4. So the square root of 4 is 2. 3 minus 2 is 1. And then plugging in the next perfect square, we would have 4. So, oops, I'm sorry, over here. So I made a mistake back here. If we plug in some x's, and then I'm going to put my two functions here to keep track of that. because I made a mistake because I was trying to do that all in my head instead of writing out some of my thoughts on paper. So the first one that we plugged in was 0. And then we did 3 minus the square root of 0, which is 3. And then I said plug in 1. So 3 minus the square root of 1, the square root of 1 is 1, is in fact 2. And then I skipped some. So we had 2, 3 we could put in, but those aren't perfect squares. So I just kind of skipped those and then put in 4 instead. So 3 minus the square root of 4, that'd be 3 minus 2, which is 1. So this is not a point, and that's a point right there. And then the next perfect square, I can put in 9. So I'm just going to skip some also. So 5, 6, 7, 8, and 9. So the square root of 9 is 3. So oh, and I'm sorry, this should have been a 1 too. I made another mistake. So if you note here, this is 3 minus 2, which is 1. So that should be right there. So my fault. Here, it would be 3 minus the square root of 9, which is 3 minus 3, which gives us 0. So in graphing that, I can see this equation is, or this graph of 3 minus the square root of x is going to look like that. I graphed it by hand, but of course you can use technology, but it always helps to be able to think about that before you graph to see what you're going to get. So if I graph 3 minus the square root of x, and then in looking at that, I have a graph that matched what I had. A couple of my points are off, and that's fine. So if I put on here now, 3 minus, and I plug in 0, the square root of negative 3 is undefined. If I plug in 1, 1 minus 3 is negative 2, also undefined. We're not going to be defined here until we hit 3. So the square root of 3 minus 3 is 0. And then we can plug in some other numbers. I know that the square root of 1 here is going to be defined. So if I plug in 4, so this would be the square root of 4 minus 3. That's going to give us the square root of 1, which is 1. And then looking for the next one, I know that the square root of 4. So to make a difference here of 4, I can take 3 and add 4. That's going to be at 7. So if I did the square root of 7 minus 3, that's going to give me the square root of 4, which is in fact 2. So I'm going to graph those points and see what happens. So at x equals 3, we're at 0. At x equals 4, we're at 1. And at x equals 7, we're at 2. So our graph is going to go kind of like this, and it looks like we have a solution at x equals 4. So I'm going to graph the other one to verify that. So y equals the square root of x minus 3. And then we see our solution. So now we're going to solve that analytically. So if I have 3 minus the square root of x equals the square root of x minus 3. We want to get rid of the square root on this side. So I'm going to square that. Same thing here. We're going to square. So I'm going to write this binomial twice. So 3 minus the square root of x times 3 minus the square root of x. And then that's going to equal the square root squared is going to go away. So x minus 3. And then I'm going to distribute 3 times 3 is 9. 3 times a negative square root of x would be minus 3 square root of x. And then that's going to happen again. So minus 3 times the square root of x. And then the minus the square root of x squared So minus times and minus is going to make positive. Square root of x times the square root of x is going to make just regular x. And then that equals x minus 3. So collecting these like terms, we have 9 minus 6 times, and I wrote the square root of 3 there. That should be the square root of x. My apologies. So let me just rewrite this real quick. So 9 minus 6 times the square root of x plus x is equal to x minus 3. So now what I'm going to do is subtract x on both sides. And that will go away. And then I'm going to get rid of the 9 by subtracting 9. So we have negative 6 times the square root of x equals negative 12. And now to get rid of this negative 6, we have to divide both sides by negative 6. And then you will get the square root of x equals 2. And then you have to square both sides, and you get x equals 4. And then we don't have an extraneous roots, and it matches what we solved. So we are all set.